They called it the Panther, the pinnacle of German tank design, a machine that had terrified Allied crews with its sloped armor and high-velocity 75mm gun. American soldiers had seen these sleek predators abandoned on roadsides, disabled in combat, or captured intact as the German war machine crumbled, but they had never actually maintained one. Not really. Not until the summer of 1944, when Allied ordnance crews finally got their hands on these captured predators and tried to get them running. They expected German engineering excellence, they expected power and invincibility. What they discovered instead would fundamentally change how Allied planners understood the hidden weaknesses that had helped doom the Third Reich. Weaknesses that went far beyond tactics or training. Sometimes the most revealing truths are found not in grand strategy, but in the mundane details of a shattered final drive. By mid-1944, the tide of war had turned. In Normandy, American, British and Canadian forces were facing the bulk of the Panzerwaffe. Behind them, supply officers worked frantically to keep tanks running. Every spare part, every transmission, every engine was a matter of operational success or failure. The American military had standardized on the M4 Sherman. Produced by the tens of thousands, the M4 was powered by reliable engines like the Wright R975 Radial. It was not the most powerful tank. Its armor was thin and its gun was mediocre, earning it grim nicknames like Ronson. But the M4 was a masterpiece of logistics. It was reliable, simple to maintain, and could be mass-produced. Its transmission and engine could run for thousands of miles with basic field maintenance. An entire engine could be swapped out in just a few hours. The American M4 could carry its crew into battle and, crucially, bring them back. Its 100-gallon fuel tank gave it an operational range of approximately 120 miles on roads. Do the math, and you get just over 1 mile per gallon. It was thirsty, but it was a predictable and manageable thirst. The German Panther, by contrast, was a different beast entirely. Developed in response to the shock of the Soviet T-34, the Panther was designed to be the perfect medium tank, balancing mobility, armor, and firepower. Where the Sherman was built for reliability, the Panther was built for battlefield dominance. The Panther was powered by a Maybach HL230 V12 engine, a sophisticated water-cooled gasoline engine producing 700 horsepower. But this is where the trouble began. The engine was a marvel of complexity, but it was dangerously overstressed in the 45-ton chassis and prone to catastrophic failure. German technical manuals were filled with desperate warnings for Panther crews. The engine was a fire hazard. Fuel pump leaks could spray gasoline directly onto the hot exhaust. Crews were warned to never run the engine at its maximum RPM for more than a few minutes, or it would seize. The vehicle carried 720 liters of fuel, about 190 gallons. On paper, this gave it a range of 250 kilometers or 155 miles on roads. In practice, under combat conditions in the mud of Normandy or Russia, that range often dropped to less than 60 miles. These were not figures that Allied intelligence had fully appreciated. When fighting a Panther, you cared about its 80mm of sloped frontal armor, which your 75mm gun couldn't penetrate. You cared about its long KWK-42L70 gun, which could kill your Sherman from 2,000 meters away. But in the summer of 1944, as Allied forces broke out of Normandy during Operation Cobra, they began to capture dozens of these formidable tanks. The story really begins in August, as US ordnance units were tasked with clearing the battlefield of wrecked and abandoned enemy equipment. They discovered something baffling. For every Panther destroyed by Allied gunfire or air attack, they found another 2 or 3 that were mechanically intact. They had been abandoned by their crews, often with demolition charges set because they had simply broken down. A young major in an ordnance recovery battalion, tasked with assessing these captured prizes, decided to find out why. His unit desperately needed heavy towing vehicles, and the Panther chassis seemed perfect. Why were the Germans abandoning their most powerful weapons? The first challenge was simply starting them. The Maybach engine was notoriously difficult, but the American mechanics, masters of improvisation, got a few running. The immediate impression was one of awe. The tank was fast, the ride was smooth thanks to its complex interleaved suspension, and the power was undeniable. But the most devastating discovery was not the engine. It was the transmission and specifically the final drive. The final drive is the set of gears that delivers power from the transmission to the tracks. In the Panther, it was a catastrophic, built-in, fatal flaw. The Germans, in their rush to get the Panther to the front, had used a simple spur gear final drive. A 45-ton tank with a 700 horsepower engine required a much stronger double herringbone gear system. The part was simply not strong enough for the machine it was in. The American crews, used to the incredible durability of the Sherman's transmission, began to test the captured Panthers. A Sherman could pivot turn on hard ground all day. The American drivers, unfamiliar with the Panther's fragility, attempted the same maneuvers. The result was immediate and shocking, the sound of stressed metal grinding, followed by a loud bang. The Panther's final drive had shattered. The tank was completely immobilized. The crews realized that the simple act of turning, a basic function of a tank, could destroy this superior weapon. They dug into captured German maintenance logs and prisoner interrogations. The picture that emerged was horrifying. The average operational life of a Panther's final drive was not thousands of miles, like a Sherman's. It was approximately 150 kilometers, or just 93 miles. This was not a design flaw. This was a logistical black hole. The Germans had fielded a tank that was guaranteed to destroy itself after just a few days of combat operations. It was a throwaway design, a disposable asset. The ordnance major did the arithmetic. To keep one Panther battalion fighting, you needed a constant stream of 5-ton final drive assemblies. You needed specialized heavy-lift recovery vehicles, like the 18-ton Famo half-track, to drag the broken tanks back from the front line. The implications were staggering. The German Panzerwaffe was being systematically bled dry, not by Allied guns, but by its own maintenance requirements. The Panther, the supposed savior of the army, was a logistical anchor that was drowning the entire German war effort in a sea of broken parts. The American officers began to understand something profound. The Germans had designed a tank that was tactically superior, but the Americans had designed a tank that was strategically superior. The Sherman was a weapon of logistics. The Panther was a weapon of desperation. As more German equipment was captured, this pattern repeated. The magnificent Tiger I tank was just as bad, if not worse. Its complex, interleaved suspension was a nightmare to repair. Changing a single inner road wheel could take a maintenance crew an entire day. The Tiger II, or King Tiger, was even more fragile. At 70 tons, its engine and transmission were pushed so far beyond their limits that many broke down before they even reached the battlefield. The Germans were building tanks that could not survive the simple act of driving to the front. American soldiers examining these mechanical failures began to notice other details. The German vehicles were over-engineered. They were built like Swiss watches, as one report noted. Every part was custom machined and fitted, making mass production and field repair nearly impossible. The M4 Sherman, by contrast, was built like a Ford tractor. It used standardized interchangeable parts. A mechanic from an artillery unit could fix a Sherman's engine. A broken Sherman could be cannibalized for parts to get two others running. It was a system built for a long, grinding war. The Germans had built for theoretical perfection. The Americans had built for reliability and sustainability. As the war of attrition in Normandy raged, the German approach proved fatal. Panther divisions were often at 30% strength, not from combat losses, but because the other 70% were in workshops. Consider the practical implications. An American armored division could count on 90% of its Shermans being operational on any given day. A German Panzer division was lucky if 50% of its Panthers were running. The Germans were losing the war in their own motor pools. The U.S. Army's ordnance teams began to see the Panther not as a predator, but as a liability. They were glass cannons, incredibly dangerous if they were in the right place, but so fragile that they rarely were. The German army was chained to these high-maintenance machines. One particularly revealing incident occurred near St. Lo. An American recovery crew found 5 intact Panthers abandoned in an orchard. They had not been hit. They had not run out of fuel. Their maintenance logs showed they were all awaiting replacement transmissions or final drives that never came. The German crews had simply abandoned their most advanced weapons and walked away. This was not a military defeat. It was a logistical surrender. The German industrial base, being bombed into rubble, could not produce the tidal wave of spare parts these fragile tanks required. The American major who had first tested the Panther wrote a blistering report. He concluded that the Panther was not a practical field weapon and that its tactical advantages were completely negated by its mechanical unreliability. This report was circulated widely. The irony was not lost on American tankers. They were fighting in a flimsy Sherman, which they cursed for its thin armor. But their flimsy tank worked. It started every morning. It got them to the battle and it got them home. The invincible Panther was most of the time just a 45-ton roadside monument. This discovery had a massive impact on Allied morale. The Panther phobia that had gripped infantry and tankers began to fade. They realized the Panther was a rare beast, and for every one they fought, 2 more were broken down in a ditch somewhere. The German military had made a fatal assumption. They believed that tactical quality on the battlefield could overcome Allied industrial quantity. They had not realized their quest for quality had created vehicles so complex that they couldn't even get to the battlefield. This had been a problem from the Panther's debut. At the Battle of Kursk in 1943, hundreds of brand new Panthers were committed. Of the 200 Panthers that started the battle, only 43 were still operational a few days later. Many had been lost to engine fires and transmission failures. The Germans never fixed the problem. The final drive of the Panther AOSF G, the late war model, was just as fragile as the first. The German war machine was trapped in a cycle of building complex, superior weapons that it logistically could not support. American intelligence officers compiled the data. They calculated that the M4 Sherman had a mean time between failure of thousands of miles. The Panther's was measured in dozens. The German army was being destroyed by its own brilliant, overcomplicated, and fragile engineering. The American GIs who had to tow these dead Panthers off the roads of France learned this lesson in the most practical way. They developed a grim respect for the tanks, but also a deeper appreciation for their own boring and inferior Shermans. After-action reports from this period are full of these anecdotes. A recovery crew jokes that they captured more Panthers with a tow cable than the tankers did with their guns. It was a dark humor born from a new and startling understanding of their enemy. The German soldier, in turn, was trapped. He was given a weapon that was superior in a one-on-one fight, but was also a mechanical curse. He lived in constant fear, not just of the enemy, but of his own transmission breaking, leaving him stranded and helpless. Some German officers, like General Guderian, had screamed at Hitler and the engineers about these problems. They knew the Panther was too complex. They had begged for a simpler, more reliable tank, but the obsession with technological perfection had won out over common sense. American planners, by contrast, had always operated under the assumption of sustainability. The Sherman was designed from the start to be repaired in a French field by a 20-year-old mechanic with a basic toolkit. This was America's true secret weapon. The Germans had built for a short, decisive war. The Americans had built for a long global industrial war of attrition. The M4 Sherman was a weapon of attrition. The Panther was a weapon for a parade, and in the fields of Normandy, the war of attrition was winning. The American soldiers, examining the guts of a broken Panther transmission in 1944, were seeing the truth of the whole war. They saw an enemy that had prioritized complexity over reliability and tactical brilliance over strategic sense. They saw an enemy that was quite literally breaking itself apart. This knowledge filtered up to the highest levels. Allied commanders like Patton, who had initially demanded a better tank, began to understand. The best tank was not the one with the biggest gun. The best tank was the one that showed up. The Shermans always showed up. The economic implications were staggering. It was calculated that one Panther cost as much to build as 4 Shermans, but the logistical cost was even higher. A Panther consumed spare parts, recovery vehicles, and maintenance man-hours at a rate that no army could sustain. By the time of the Battle of the Bulge in December 1944, this crisis reached its peak. German panzer units, equipped with Panthers and Tigers, began the offensive. They were immobilized almost immediately, not just by lack of fuel, but by massive mechanical breakdowns on the icy roads. Entire columns of brand new Panthers were found abandoned. their final drives shattered by the strain of the Ardennes terrain. The last great German offensive had been defeated in large part by the same fragility that the ordnance crews had discovered in Normandy. The Panther tank was not a warhorse. It was a thoroughbred. It was beautiful, powerful, and fast, but it was so fragile that it was useless in a real, dirty, protracted war. The American Sherman was the mule. It was ugly, slow, and unglamorous, but it just kept pulling. The American GIs who drove captured Panthers quickly lost their enthusiasm. They found themselves spending all their time trying to fix the complex engines and transmissions, constantly worried that a simple turn would strand them. The prize had become a burden. The broader lesson was clear. German equipment looked impressive. But it was not built for the war it was actually in. It was built for a fantasy war, where parts never broke and maintenance was never needed. The American military had built for the war it knew it would fight. General Eisenhower had said that amateurs talk strategy, professionals talk logistics. The Panther versus Sherman debate was a perfect illustration. The Panther was the amateur's choice. The Sherman and the massive logistical system behind it was the professionals. So when we remember the tank battles of World War II, we should remember this hidden truth. The truth discovered by mechanics in a muddy field in France. The truth that the best tank in the world was a logistical nightmare that crippled its own army. The German quest for technological perfection had not created a war-winning weapon. It had created a beautifully engineered trap. The Panther was a symbol of a war machine that had become too complex, too fragile, and too obsessed with quality to actually win. The German tank crews who had to fight in the Panther lived a life of profound contradiction. They possessed a tank that could dominate the battlefield, but they lived in constant gnawing fear of it breaking down. A strange noise from the transmission was more terrifying than an incoming shell. Post-war interviews with Panther veterans are filled with these stories. They describe nursing their tanks, avoiding sharp turns, never pushing the engine, and coasting in neutral downhills to save the transmission. They were driving a 45-ton sports car made of glass. This fear paralyzed German tactical decisions. Panzer commanders, who should have been maneuvering and flanking, were forced to adopt static defensive positions. They didn't dare move their tanks unless absolutely necessary, knowing that a simple 10-kilometer road march could disable half their unit. The American forces, by contrast, had total confidence in their machines. A Sherman division could be ordered to move 100 miles, and the commanders knew with certainty that 95% of the tanks would arrive. This logistical confidence allowed for the kind of fluid, mobile warfare that Germany had invented. Ironically, the Blitzkrieg doctrine, built on speed and operational mobility, had been made impossible by Germany's own overcomplicated tanks. The Panther was the antithesis of the Blitzkrieg spirit. It was a weapon that enforced slowness, caution, and passivity, because it was a mechanical liability. The American ordnance crews who studied these wrecks were not just mechanics. They were forensic scientists discovering the cause of death of an entire army. The cause was not Allied armor, but a systemic, self-inflicted logistical failure. Germany was committing suicide by engineering. The German High Command was not entirely ignorant. General Heinz Guderian, the Inspector General of Armored Troops, wrote scathing memos about the Panther's unreliability. He complained that the troops had been sent a work in progress rather than a finished weapon, but it was too late. The German war machine was trapped. It could not stop producing the Panther, as it was the only tank that could counter the T-34 and Sherman Firefly. But it also could not fix its fundamental flaws without a complete redesign, which it lacked the time and resources to do. The American industrial base, by contrast, was a marvel of flexibility. The M4 Sherman was not one tank, but a family. It was built by 10 different major manufacturers, from Chrysler to Ford. This decentralized mass production system was impossible for Germany's artisan factories to match. When a flaw was found in the Sherman, such as its tendency to catch fire, a solution was engineered. Wet stowage for ammunition was rapidly introduced, dramatically increasing crew survival. The Panther's engine fire problem, present from its debut at Kursk, was never adequately solved. The American system valued the crew. The The Sherman had large escape hatches and a reliable design. The German system valued the hardware. The Panther's crew, while protected by thick armor, was in constant danger from its own machine, either from fire or from being stranded deep in enemy territory. The production numbers tell the full story. Germany, with its entire industrial base focused, managed to build approximately 6,000 Panthers during the entire war. The United States, while also fighting a war in the Pacific, built over 49,000 M4 Shermans. This was not a 1-to-8 disparity. It was far worse. Because of the Panther's unreliability, Allied intelligence estimated that for every one Panther operational on the front line, there was at least one more in a maintenance depot. The actual number of fighting Panthers was a fraction of the total built. The U.S. Army, by comparison, consistently maintained an operational readiness rate of over 90% for its Shermans. The logistics system, from the factories in Detroit to the mobile workshops in France, was a well-oiled machine. The German system was a series of chaotic, failing workshops. The American mechanics who had to deal with the few captured Panthers they tried to use quickly gave up. The vehicles were maintenance queens that consumed more man-hours than they were worth. They were quickly scrapped or sent to the rear for testing at Aberdeen Proving Ground. At Aberdeen, the engineers confirmed everything the field crews had discovered. They ran the Panther's engine on a dynamometer until it seized. They analyzed the metallurgy of the shattered final drive gears and found them brittle. The design, they concluded, was fundamentally unsound for a weapon of war. This report was a devastating indictment. The best tank of World War II, as many called it, was a failure as a weapon. A weapon, the report argued, is not just its gun and armor. It is the sum of its reliability, maintainability, and logistical footprint. By that measure, the Panther was a disaster. The German obsession with quality had, paradoxically, resulted in an unusable product. The late-war Panthers, built by slave labor in bombed-out factories, had even worse quality control. Final drives were made with poor quality steel, guaranteeing they would fail even faster. The American GIs and mechanics had discovered the truth. The German war machine was not a steel behemoth. It was a hollow giant, a colossus with mechanical feet of clay. It looked terrifying, but a close inspection revealed it was rotting from the inside, undone by its own complexity. The Panther, therefore, represents a perfect lesson in military design. It proves that a weapon's tactical perfection is useless if it is not strategically sustainable. A tank that wins every duel but breaks down on the way to the fight is a net loss for the army. The German crews were, in essence, the final component of their over-engineered tanks. They were asked to compensate for mechanical flaws with their own courage and skill. They were being asked to win a war that their own engineers had already made logistically unwinnable. The Battle of the Bulge was the Panther's eulogy. Entire Panzerkampfgruppen were annihilated, not by Allied action, but by their own mechanical failures. The roads of the Ardennes became a graveyard for Hitler's last armored reserve. The tanks abandoned exactly where they had broken down. American soldiers, advancing past these steel corpses, saw the truth. They saw Panthers with their tracks thrown, Panthers with oil pooled beneath their hulls, Panthers sitting silently, useless, not a scratch on their thick frontal armor. They had been defeated by their own transmissions. The M4 Sherman, by contrast, chugged along. Patton's Third Army was able to make its famous 90-degree turn and race 100 miles north to relieve Bastogne. That maneuver, a logistical miracle, was only possible because his Shermans worked. A Panther division could never have done it. The Panther's story is a story of arrogance. The arrogance of engineers who believed they could defy the laws of logistics. The arrogance of a high command that believed tactical superiority was a substitute for industrial sustainability. It was a fatal, national arrogance. The American approach was one of humility. The Sherman was a good-enough tank. Its designers knew it wasn't the best, but they also knew it could be produced in the tens of thousands. And they knew, above all, that it would run. That humility won the war. When American forces captured the Henschel and Mann factories at the end of the war, they were stunned. These were not the assembly lines of Detroit. They were glorified workshops, reliant on skilled artisan labor. It was a 19th-century manufacturing system trying to fight a 20th-century industrial war. The Panther was a product of this workshop mentality. Each one was a semi-custom built machine. Its parts were not interchangeable. This is why field repair was so impossible. The German engineering that was so admired was, in fact, their greatest strategic weakness. The American system was the opposite. Simplicate and add lightness, as the saying went, the Sherman was designed for mass production. Its parts were interchangeable, whether the tank was built in Michigan or Pennsylvania. This was the true source of Allied power. The Panther's legacy, therefore, is not as a war-winning weapon. It is a cautionary tale. It is the single best example of how a nation can be seduced by its own technological prowess, creating weapons that are too complex to field and too fragile to fight. The German soldier, who had been promised a Wunderwaffe, wonder weapon, was instead given a work in progress that was prone to self-destruction. His faith in his equipment, a core part of a soldier's morale, was shattered. He was not just fighting the Allies, he was fighting his own tank. The American GIS, who climbed into those captured Panthers in 1944, discovered this truth firsthand. They expected a monster, and they found a fragile, high-maintenance invalid. The fear of the Panther was replaced by a kind of pity for the men who had to use it. This story, the story of the broken final drive, is the real story of the Panther. It is more important than all the long-range kills it ever made, because a tank's true measure is not its gun. It is its ability to get to the battle. The Panther was, in the end, a tactical masterpiece and a strategic catastrophe. It consumed resources that Germany desperately needed for simpler, more reliable weapons like the Stugge 3 assault gun. Every Panther built was a mistake that hastened Germany's defeat. The American mechanics and ordnance officers who wrote those obscure after-action reports were the first to understand this. They didn't just see a broken tank, they saw a broken war machine, an enemy that had been defeated by its own obsessive, perfectionist and fatal engineering. The German quest for a perfect tank had blinded them to the realities of a total industrial war. They had forgotten the most important rule. Quantity has a quality all its own. But the Allies had an even better rule. Reliability is a quality. The final analysis from Aberdeen Proving Ground was simple. The Panther was a brilliant failure. It had pushed the boundaries of tank design, but had ignored the fundamental requirements of logistics and reliability. It was a tank built to be admired, not to be fought. The M4 Sherman, on the other hand, was built to be fought. It was built to be repaired, to be upgraded, and to endure. It was the physical embodiment of the American industrial philosophy. Good enough, on time, and in overwhelming numbers. The Panther's story is a story of how a nation can be defeated by its own strengths. German engineering was its greatest asset, and it became its greatest liability. The obsession with perfection led directly to mechanical and logistical paralysis. The American soldier who cursed his Ronson Sherman was actually driving the war-winning weapon. He was driving a tank that was part of a system of interchangeable parts, of rapid field repair, and of relentless, overwhelming industrial sustainability. The abandoned Panthers that littered the roads of France and Belgium were tombstones. They were not monuments to Allied firepower, but to German logistical collapse. They were steel testaments to the fact that, in modern war, the most important battle is the battle of maintenance. The German soldier had been given a sports car to fight a tractor's war. The American soldier had been given the tractor. In the mud and grit of a world at war, the tractor, the reliable workhorse, would always win. The invincible Panther was, in fact, one of the most fragile and problematic weapons of the entire war. Its crews were sent to their deaths by a design philosophy that prioritized a single battle tactical edge over the long-term strategic ability to wage war. This fatal trade-off, made by Hitler and his engineers in 1942, was paid for in blood by the Panzerwaffe. It was a compromise that gave them a formidable-looking tank, but one that was a mechanical ghost, rarely present on the battlefield in the numbers needed. The US industrial machine, by comparison, was a marvel of the modern world. Factories like the Detroit Arsenal were churning out Shermans at a peak rate of 100 per day. That was more tanks in a single week than the Germans could build in a month. These factories were staffed by a new army of workers, including thousands of women, Rosie the Riveters, who built the complex engines and welded the hulls. This mobilization of the entire civilian population was something Germany's artisan-based system could not match. So while the German army was still trying to fix the Panther's original 1943 design flaws, the US Army was already mass-producing upgraded Shermans, the M4A3E8 with a new gun and suspension, and the M4A3E2 Jumbo with heavy armor. The pace of reliable innovation was relentless. For the German tanker, the war was a terrifying logistical nightmare. He went from being the hunter to the hunted, not by enemy tanks, but by his own faulty transmission. His aircraft, once a symbol of pride, became a symbol of his nation's inability to deliver a working machine. When the war ended, American forces found hundreds of Panthers at maintenance depots and factories. Many were brand new, straight from the assembly line, but had been abandoned because they could not be moved or were waiting for parts that would never arrive. The examination of these surviving tanks confirmed what the field crews had first discovered. They were masterpieces of complexity, but they were not weapons of war. They were fragile, over-engineered, and, by 1945, completely unsustainable. The Panther's story is the ultimate lesson in military procurement. It proved that a weapon system must be judged in total: the gun, the armor, the reliability, the maintainability, and the production cost. The Germans had only looked at the first two. The American GIS, who had to tow these 45-ton monsters, were the first to understand the full picture. They learned that industrial might matters, but logistical intelligence matters more. Building a reliable machine is a greater strategic victory than building a perfect one. The invincibility of the Panther was a myth. It was a myth born from a few terrifying encounters. When that myth collided with the industrial reality of the United States and the spreadsheet of a US ordnance major, it evaporated into a cloud of broken gear teeth. The crews of the Panther, who climbed into their complex cockpits, were some of the best trained tankers in the world. They were sent to die by a design flaw, sacrificed for a superior gun by a high command that had lost touch with the mechanical realities of war. The lesson from the fields of Normandy was simple: no weapon is a secret for long, and its weaknesses, whether a thin piece of armor or a fragile final drive, will be discovered and exploited. The Panther's weakness was its own complexity. The Panther was not just defeated by a better tank, it was defeated by a better system. A system of mass production, of superior logistics, of rugged design, and of an engineering philosophy that valued reliability as a weapon in itself. The Panther's story began with a desire to create the perfect tank and ended with the creation of the perfect logistical nightmare. It is a perfect arc of military hubris, a testament to what happens when a nation's reach exceeds its industrial grasp. The confidence of the German High Command in 1943 was real, but it was based on a false premise. They believed a wonder weapon could save them. They didn't realize that wonder weapons, if they can't be maintained, are just scrap metal waiting to be towed away.